Here is a question on general organic chemistry. Read the question carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Heat of hydrogenation, delta-H_HYD, is the energy released when a double bond is hydrogenated. A more stable, more substituted or more conjugated alkene has lower potential energy, so it releases less heat upon hydrogenation. Conversely, a less stable alkene releases more heat. Therefore, stability order is inverse to heat of hydrogenation order. Step 1. Assess stability of each alkene. Structure: I1, 2-dimethylcyclohex, 1-Na has a tetrasubstituted endocyclic double bond, 2 ring carbons each bearing a methyl group and 2 additional ring carbons as substituents. This is the most highly substituted double bond, most stable, lowest heat of hydrogenation. Structure: 2,1-methylene, 2-methylcyclohexane has an exocyclic double bond, is equal to CH2. The exocyclic carbon bears no substituents, is equal to CH2's terminal, and the ring carbon bears the ring and a methyl group. Exocyclic double bonds are generally less stable than endocyclic disubstituted ones. This double bond is monosubstituted on the ring side, less stable than I, but must be compared to 3. Structure: 3,3,4-dimethylcyclohex, 1-Na has an endocyclic double bond between C1 and C2 with no substituents directly on the double bond carbons. The methyls are on C3 and C4, not on C1 or C2. This is essentially a disubstituted endocyclic double bond. Each vinyl carbon has one ring carbon substituent, but with no additional alkyl groups directly attached, making it less substituted than I, but comparable to or slightly more stable than 2. Step 2. Compare 2 and 3. Exocyclic methylene is equal to CH2. Double bonds are less stable than endocyclic double bonds of comparable substitution because endocyclic double bonds benefit more from hyperconjugation and ring geometry. A monosubstituted exocyclic double bond, 2, is less stable than a disubstituted endocyclic double bond, 3. Therefore, stability, I3-2. Step 3. Heat of hydrogenation, inverse of stability. Stability order, I3-2. Heat of hydrogenation order, 2-3I. Step 4. Verify against options. Option C states 2-3I, which matches our analysis. Why other options fail? A. I2-3 would mean I is least stable, incorrect, I is most stable. B. 3-2I would mean I is most stable but 3 releases most heat, incorrect ordering of 2 and 3. D. 3I2 would mean I is intermediate, incorrect, I is most stable and should have lowest heat of hydrogenation. Therefore, the correct answer is C. Therefore, the correct answer is option C.